Hi there, welcome to AP Environmental Science, Chapter 15, Lecture Part 2. This is the second half of our freshwater chapter, so let's begin. What happens with water? Well, we were talking about floodplains in one of our last sections of our notes, our lecture. So let's talk about flooding. Well, flooding is a natural event. When it rains or too much water is flowing, there's going to be natural flooding occurrences. These are natural things for rivers to do. Their volume is not always stagnant, it doesn't stay the same. All right. So we have storms, a lot of drainage, all the water on the land and that watershed ends up draining in the tributaries and to the river, and the rivers will naturally flood. Bodies of water near an ocean, they will naturally flood. If the tide gets too high, and the oceans are rising, everybody, we're going to talk about that in another chapter, but as the tides get higher and higher because the oceans are rising, we're going to have coastal areas impacted. What are levees? Levees are structures that are built that prevent flooding, basically. They're along the banks of waterways. Well, this is New Orleans, and what happened in New Orleans, we had a hurricane called Hurricane Katrina, and that hurricane created a massive storm and the ocean levels rose. What happened there? Well, New Orleans, I believe, is built slightly below sea level, which isn't a smart way of building a city, but it was done that way and it's there, so they're not going to move it. It's not so simple. When the ocean level rose, the levees were not tall enough to hold the water back, and the levees broke, basically meaning the water went over the levees and flooded New Orleans. New Orleans got flooded as a result of their levees not holding back enough water. So we build levees to prevent flooding. These are the levees right here. Dams. What are dams? They're obstructions. They block the flow of water. Why do we generally build them? So we can divert water from one place to another. That's one reason. And another secondary reason, or a primary reason in a lot of cases, is to produce electricity through hydroelectric plants. Reservoirs are artificial lakes. We build them all the time to store water for ourselves. All right. Now, this shows you positives and negatives of a dam or a diversion of a river in this case. The green is positives. The orange here is not good things that happened, negative impacts. So let's go through positive impacts of rivers. One of the major positive impacts of damming a river is hydroelectric power generation of electricity. This generation of electricity creates no emissions, so there's no gases produced as a result of this. It is just electricity. It is sustainable. It's not. It's going to always be there as long as water is there. It'll be there. It's not utilizing any other sources to produce the electricity other than the motion of the water, basically. Why do they build dams in a lot of cases? Well, they control flooding downriver, downstream, because there's less water flooding that way, moving that way. Even although they control flooding maybe downstream, they might create more flooding upstream. So there's negatives and positives that go with that. What are they used for? Irrigation. A lot of times this fresh water is used to irrigate things. So that's why you'll dam an area so that you have plenty of water for irrigation and drinking water. People use dammed areas for recreation. A lot of it is recreational also. So these are positives of building a dam. Negatives, well, you get a lot of sediment behind the dam. It affects flooding cycles and things of that nature. All right. The sediment is now not going downstream where floodplains and riparian zones would be receiving that sediment and making their soil more nourished and more fertile. So it's affecting it that way. There could be a chance of it failing and becoming a catastrophe. This happened almost in California recently when we had some storms. Everybody was worried about the dams up in Northern California. Biggest impact of a dam, huge one, if you're talking about environmental science, is habitat change, habitat alteration. You have all this habitat is changed downstream and even upstream. Now you have more water where you had less water. All right. Downstream, if you live downstream from the dam, well, now you don't have as much water, so you've lost recreational activities while they've gained them up here. Downstream, your fisheries get destroyed, basically. There's less water, there's less fish, the water gets warmer, thermal pollution, we'll talk about that in a little bit. Fish cannot migrate, they can't move back and forth the way they migration cycles for spawning, those are disrupted. And basically, Disruption of flooding that builds up. So there's major disruption here. You need flooding down here for the topsoil to get its silt and get its nutrients, and you don't have that if you have this blocking the flow of water all the time, or most of the time. That is. The largest dam in the world is called the Three Gorges Dam. It's in China. It is massive. It is huge. When they built it, people were displaced. They said, you got to leave where you live. You can't live here anymore. This creates a lot of electricity. I'm sure that was the primary intention of the Three Gorges Dam, probably was to create electricity. You have over 1 billion people over there. You're talking about, they do utilize a lot of sustainable energy resources in China as a result of knowing that they have that many people there. But this dam is massive, huge environmental problems. And the examples I explained to you earlier are a lot of them. All right, so what's happening around the world? Well, they're removing dams in a lot of places around the world. And why are they removing them? They're realizing that the aftermath is worse than what they're getting out of the dam. Well, they're trying to restore the riverside habitat or the riparian habitat. Fisheries are destroyed, and that's a food source. Recreation downstream, people are ticked. If you live downstream, you're getting screwed over in a sense. The estuary where the river flows into the ocean, the river mouth, is massively disrupted by dams. So disrupted that the shellfish in that area, the fish in that area, they're not thriving because of the lack of nutrients and nourishment that would come downstream from the river. What are people doing to make more fresh water? Well, the two major ways of purifying water are desalination, distillation and reverse osmosis are the two main ways. All right, people primarily, desalination doesn't really happen here in the United States that much. And why? Desalination, removing salt from fresh water, is very difficult to do. It requires a lot of energy to do it. It requires so much energy to do it that it's not the smartest way of getting fresh water. Where do they do a lot of desalination? In the Middle East, there's a lot of desalination plants. They're using their fossil fuels, their oil, and they're basically distilling or pumping water through membranes using reverse osmosis. Distillation is where you evaporate, so it requires a lot of energy to do distillation. You boil water and you collect pure water in another chamber somewhere else. So it leaves, the water becomes a vapor, and the vapor gets collected somewhere else, and then it condenses and becomes water. What is left behind with distillation? A lot of salt is left behind. So you get a massive amount of salt behind. Reverse osmosis is pumping water through filters. Why is it called reverse osmosis? Because osmosis means water naturally wants to go to where there is more salt. But reverse osmosis is like, no, we want the water to go away from the salt. So it's basically pumping water through filters. Those filters are membranes that can block salt from passing through. So what's left on the other side is just water. In order to do that, you got to pump it. So it requires energy to do that. All right. Like I said, desalination, very expensive because it requires a lot of energy input. All right. So I mentioned earlier, we're told to cut our water usage in our municipal or our family, our domestic use, but ideally agriculture uses so much water. Their small changes would equate to our large changes. How can they do that? If you line the canals, which means water won't seep into the ground as easily, with things to prevent leaks. What do they line them with? Clay usually. Leveling fields so you don't have as much runoff. So if you don't have slopes everywhere, you won't have water running off. It'll stay where you intend it to stay. Basically using different irrigation methods like drip irrigation, where the water goes directly to the roots below ground and you have less runoff, less evaporation. Growing things, crops that don't use quite as much water. Almonds, for example, oh man, they're very water intensive. Certain fruits and vegetables are very water intensive. Almonds are a very common one. Avocados are in that family of water intensive fruits or vegetables, basically. What happens? What have people done to their yards to help preserve water? Well, this is what's happening, xeriscaping. People are putting rocks out or mulch or artificial turf. Ideally, people are putting in plants that are native. Native plants to San Diego don't need a lot of water. right? So you don't need to water them a whole lot. These rocks are here instead of grass because grass requires a lot of water. So this is xeriscaping. This is what people are doing in their landscape so that they can preserve water. Common thing in San Diego because we've been told to conserve water for years and we're not allowed to water our grass. So a lot of people don't have grass anymore. They have a lot of plants that are like this basically. What else can we do to just save water? Well, we don't get a lot of rain in San Diego, so you don't see a lot of rainwater harvesting in San Diego. They're basically canisters, kind of like on your rain gutters, and they connect to your rain gutters of your house, and they collect water. What can this water be used for? Watering your lawn. A lot of times, some people save the water from their showers and sinks. That's called gray water. This can all be used for watering and irrigation your plants and outdoors. All right, water pollution. Two kinds of pollution in general. This isn't just water. This could be air pollution. A point source and a non-point source. Point source, you know the exact point, the discrete location. A non-point source could be many locations are polluting in a similar fashion. What would be a non-point source? Like a neighborhood, basically a residential area, all the streets coming, all the stuff coming from all the cars from the area, farming areas. It's not just one farm. If it was one farm, point source. If it's a farming area, it's a non-point source. All right, so larger areas, non-point source; smaller discrete locations, point source. And you have this picture in your textbook showing you examples of non-point sources. All these farm areas, if it was one farm, it would be a point source. All right, so if it was from a feed lot, it would be a point source. If it was from a whole farming community, all the farms are dumping pesticides probably, so that would be non-point. If it was one farm or one feedlot, it would be a point source. All right, you have this picture in your textbook showing the difference. Point sources, specific locations, non-specific locations, or a combination or an accumulation of a bunch of locations within an area. So water pollution, what kind of water pollution do we have? There's many different forms. In farming areas, a lot of pesticides. Petroleum products end up there. We have petroleum products in our cars. These products come from a lot of things. Plastic could be considered potentially, plastic is made from petroleum, so a lot of potential water pollutants. Heavy metals come from mining and things of that sort. When we break into the earth to take minerals, we release a lot of these nasty metals. Acid rain and acid rain dissolves a lot of these metals, leading to mining runoff. All right. Another water pollutant, microorganisms, and we're going to talk about bacteria and things of that sort. So biological pollution, the bacteria. When you measure bacteria, you're generally looking at they measure a sample of water, and in a 100 milliliter sample of water, they're looking for 200 colonies or fewer, all right, for it to be safe. If they get more than that, then that body of water there'll probably be a sign posted saying, don't get in the water. It's not safe. Basically, there's a lot of bacteria. What kind of bacteria they're testing for? Fecal. So a lot of people here in San Diego, we have the children's pool in the La Jolla area. A lot of times, you're not supposed to swim there. There's seals there. Those seals have pooped in the water a great deal, excreted fecal matter in the water. So that water in that area has a high quantity of fecal matter in it from those seals. It's usually off limits for swimming as a result of that. Other things that can be found in fresh water, giardia, typhoid, hep A, things that are found in water. Yeah. All right. Nutrient pollution, we talked about earlier, that can lead to a eutrophic lake. Fertilizers are the ones that lead to eutrophic lakes. Nutrients come from the fertilizers. Clear cutting an area, cutting down everything basically, increase erosion, and you get sediment pollution like this, basically. Thermal pollution, well, a lot of times the water gets warm. Thermal pollution happens when factories are using water to cool themselves. It's very common, very common. San Onofre used to use the ocean water nearby to cool the reactors. When the water gets warmer, it holds on to less oxygen, so the water becomes more towards the hypoxic end. Less oxygen in the water. Fish, plant life, shellfish do not want to be in the area if there isn't much oxygen in the area. Waste, human waste is another type of pollutant. Manure and waste, pulp from paper mills. These are organic wastes. Yard waste, more organic waste. All these organic wastes are considered biodegradable. Okay, but but if you put all this organic waste and it starts decomposing, the oxygen levels will decrease in the water as a result of it when it's decomposing, which is what happened to when eutrophication takes place. When all the algae decomposes, oxygen levels are lower. So all these things in water are not good because they increase the rate of decomposition, which decreases oxygen levels. Wastewater is water that could leave your household, for example, water due to human activities, water from our toilets, our sinks, our dishwashers. And within our dishwashers, we might have detergents and washing machines, and those detergents also can cause eutrophication. pH of water is an important factor because when pH changes, life in the water may not be able to live there. So pH can signify what life is selected for. Freshwater lakes, generally between 6 and 8, they want to be about neutral, generally neutral. Between 5 and 6, the lake starts shifting. It's not very healthy anymore. Things will start to die. When it gets in the 4s, it's probably acid shock. When acid rain occurs, and we haven't got that chapter yet, but we'll talk about that soon. What acid rain does is it leaches and releases and dissolves metals and minerals like aluminum from soil. Aluminum ends up as runoff water, makes its way to a body of water like a lake or a pond, and that lake or pond drops its pH to like a 4 or a 3. That acid shock will kill all the fish and all the living things in that body of water. Ocean, in case you didn't know, is between an 8 and 8.3, so the ocean is slightly basic. Freshwater fish like neutral, ocean fish slightly basic. Groundwater pollution, man, this is a problem. Near my mom's house where she lives in Fletcher Hills area, there was a gas station when I was a kid, and the gas station had tanks, and those tanks over time were leaking gasoline into the groundwater in that area. And that happened, this happened, I'm not kidding, about 30 years ago, and the ground is still not healed from that pollution that happened below it. They measure samples of the groundwater every so many years because they are not allowed to develop that land until the water below it has is cleared of those chemicals, and it is not. So therefore, 30 years later, there still is barren land with all these pipes going in the ground because they're constantly testing it. So groundwater pollution is a problem because groundwater basically gets replenished so slowly, it's not getting filtered out and purified. Okay, so when something gets down there, it generally stays there until it breaks down, and things can break down very slowly. Certain chemicals that are in groundwater naturally are these aluminums and fluorides and nitrates, sulfates. Where do they come from? Rocks. Rocks have chemicals in them, so rocks will naturally put things in the water. Humans, well, what we do is we build storage tanks and facilities, and these things leak. There's a problem right now near Qualcomm Stadium where they're building the new San Diego State facilities for their stadium. One of the problems with Qualcomm Stadium building a new stadium for years is that the ground below it, the groundwater is polluted. The tanks next to it were leaking organic carcinogens and different types of gases and liquids under gases under high pressure become liquids into the ground, basically. So those tanks nearby were doing major damage to the groundwater near Qualcomm Stadium. What have we done? We passed the Clean Water Act in 1977. It's been amended also to help basically prevent problems with our water and contaminants of our water and control those levels. Depending on which party is in office, sometimes there's deregulation of these rules, and sometimes there isn't. Sometimes they're made stronger. So water is a big deal. Getting fresh water and keeping our water fresh is a big deal. What do we do to drinking water? Well, we treat it in different ways. One of the ways you treat water, basically, and so when water from a reservoir or aquifer gets treated, all right, so we have to treat it before we send it to your house. So what do? Well, they do certain things. They first want to remove these particulates, these things that might be settling in the water, all right, like solid objects. Then it gets filtered. That filtering removes impurities and bacteria and microorganisms, basically. And then to make sure we got all of the microorganisms, we disinfect it with chlorine. If you live close to the plant, the water purification plant, or the water treatment facility, your water generally has more chlorine in it the closer you are to the treatment facility. They try to put enough chlorine in the water so that the water is disinfected all the way until its farthest source from the treatment plant. So the closer you are, the more chlorine you're going to get. Your water may even smell a little chlorinated if you live near the treatment facility. All right. So what do they test for? 90 different contaminants are tested for. Septic systems. Some people, if they live on a property that doesn't have or not connected to the sewer lines, they will have a septic tank or septic system on their property. A septic system does pretty much the same thing as a sewage treatment facility does, but it just does it in a smaller system or a smaller setting. What do they generally do? They first separate solids and oils from water, all right? Then the water travels downhill down through gravel and trenches, and where through the gravel it's getting filtered, basically, and then a lot of the debris is naturally decomposing. It's pretty much a septic system is a sewage treatment facility, but a smaller version of it. You probably have to have service of your septic tanks where someone or a facility will come out and probably remove solids and oil debris from your tank. So primary treatment is secondary treatment. Primary treatment basically is the first part, removing the solid stuff. They're removed in settling tanks. Secondary treatment is where you use bacteria and you naturally decompose and break down parts of it. And you might add chemicals to disinfect. And I'll show you the picture of it in your textbook. So screens and tanks, settling tanks, water gets moved around and settled. All right. So oils and greases and solids are removed. This is primary treatment. Then you aerate it, which means you pump air through it and you have microbes and bacteria pumping through it. Why air? Because the bacteria likes oxygen, and then it can decompose it and start breaking it down in secondary treatment, where it's then filtered and disinfected with UV filters. It's filtered through coal, chlorine, you name it. That's what they'll use to kill the microorganisms at the very end. And they pump it out, basically. All right. That is our lecture today.